Okay guys, and this is the second question. Sketch a graph of the function f of x, x to the fourth plus x, 4x cubed plus 20 using all the information you can gather from the first derivative test and using second derivative sign chart. So first of all, this question is asking us for the first derivative test and then the second derivative sign chart. So to get to the first derivative, you need to find your function, and our function right here is f of x equals x cubed plus 4x, x fourth plus 4x cubed plus 20. This is our function. After this, we need to find the derivative of this function. So how that works is that we divide each term. We don't divide it, we just separate each term according to sum and difference rule. But right here it's just sum. So right here we have x fourth, and that's power rule, so it would be bring down the power, keep the same base, minus 1 plus constant multiple, you bring down the constant multiple, and then you apply the power rule to this, so it's going to be bring down the power, same base, minus 1, and constant rule indicates that you just need that each constant equals 0. So right here you simplify it, and it's 4x cubed plus 12x squared. After you do this, you need to make this function equal to 0 to find possible critical points. Right here we see that we have a common factor, 4 and x, so 4x squared x plus 3 equals 0, and then right here this equation we're going to make it equal to 0, x plus 3 equals 0. We move the 3 to the other side, and x minus 3. And over here, we make this equation equal to 0, 4x cubed equals 0. So then x equals 0. And these are our two possible critical points. After we have found this, we need to make a sign chart. The sign chart looks a little bit like this. Prime on the top and F bottom, and then right here -3 is our first possible critical point, 0 is our second one.
Our first possible relative extreme.
So then here we go, start from negative infinity to -3, -3 to 0, 0 to infinity. And in order to find what sign this is, if it's positive or negative, we need to get a point that's lower than -3, and then we plug it into this equation. So right here we can get -4, plug it into the equation. So 4 times 4 is 16, and then times 12, that's a positive number. And then over here, 4 times 4 is 16, and then times -4, it's going to be a negative number. So this equals a negative sign. And we do the same for this one right here. We get a number that's in between -3 and 0. So a number between -3 and 0 is -2. So then we apply it to this function again. -2 cubed plus 12 -2 squared. So -2 times -2 is 4. And then times 12, it's going to be 48. -2 times -2 is 4, times -2 is -8, and then -4 times -8 is going to be -32. So right here we get a positive number. And we do the same thing for the last one. Right here we get a number that's greater than 0, so 1. We apply it to the function once more. Times 1 is 2, times 12 is 12, 1 times 1 times 1 is 1 times 4. So right here we get a positive number once again, and this indicates that our chart is going down, and then it goes up once more. And right here we can indicate that right here is our local extrema, which x equals -3 is our local minimum.
Okay, so to continue finding information to sketch your graph, you're going to do the second derivative sign test. So to begin that, we're going to take our first derivative that we found, which was f prime of x equals 4x to the third plus 12x squared. So from here, we're just going to do our basic derivative rules to find the derivative. Since this is a sum function, we're going to find each derivative individually. So this goes constant multiple power rule, so you bring down the 3 to the 4, which gives you 12x n minus 1, gives you 2. Plus, bring down the 2 to the 12, so 24x. Okay, so now that we found that, we're going to set this equal to 0 to find our inflection points. These inflection points are going to show us where the concavity of the graph changes. So once you set that equal to 0, to find the inflection points, you can factor out a 12x. Oops, I'm sorry, this will be 24x, since 12 times 2 is 24. So you can factor out a 12x, leaving you with x plus 2 equals 0. If you set this equal to 0, you'll get x equals 0, because 12 divided by 0 is 0. If you set this equal to 0, you'll get negative 2 basic algebra. So these are your inflection points. So with these, you're going to do the sign chart again, but this time with the second derivative to test for concavity. So you'll put f double prime, since it's the second derivative, and f your function. And then you plot your inflection points, negative 2 and 0, and you want to plot them in the correct order. So draw a line, and then you'll write your intervals, negative infinity to negative 2, negative 2 to 0, and then 0 to infinity. Then you're going to repeat the same process that you did, which was substituting a number in each interval into the first derivative function. So here we can use negative 3, here we can use negative 1, and here we can use 1. So if you substitute negative 3 into this function, times negative 3 plus 2, this will give you a negative number times a negative number is equal to a positive number. So this will be going positive, and the concavity of your graph will be going up. So this will be the shape. The next interval, 12 times negative 1, times negative 1 plus 2. This is equal to a negative number plus a positive, times a positive number is equal to a negative number. So the concavity of the graph will be going down. And finally, 12 times 1 times 1 plus 2, a positive number times a positive number is equal to a positive number. So the concavity of the graph will be going up. So with all this information that we've gathered, we can now sketch the graph. So if we draw our graph right here, and add the points 1, 2, 3, just to start, negative 1, negative 2, negative 3. Our local minimum that we found is x is equal to negative 3, so we can mark the point here. And then by looking at the shape of the graph from the information that we found, we can see that the graph first starts with the concavity going like this, reaching the minimum point of 3, going back up, and then changing inflection points at negative 1, so going down. And that is a sketch of your graph.